In this video, we're going to use the annuity formula in section 7.3 to find the regular payment or deposit amount that we need to make into an annuity in order to get a given future amount. Okay, so this is the same formula that you've seen in some other examples. There is another video as well that explains how this formula works if you're looking for A. But essentially in this video, we're going to be looking for capital R. Again, just for kind of recapping this information that's up here at the top in the paragraph, A is the future amount, R is the regular payment or deposit amount in dollars. Lowercase r, little r, is the interest rate written as a decimal. M is the number of compoundings in a year. And N is the number of periods of compoundings. And the way to find that is M times the number of years. So here, pause the video for just a second to read this problem statement. And let's see if we can identify the key parts of our formula. All right, so really the question is asking, what are her monthly payments into the account? So in other words, we're looking for R. Notice where R is in our formula. It is not isolated. So that means we're going to have to do something a little bit different here in order to obtain R, but it's not too much of a stretch. A is the amount that is in the account after it is set for some time, and that's this value. She wants her future amount to be $600. The monthly interest rate, annual interest rate is 4.8%, but written as a decimal would be 0.048. The number of compoundings in a year, let's see, this one would be, it would be implied that M is 12. I know that's not very explicit here, but because we're making monthly payments, that's again kind of implied there about the compoundings. N is the total number of periods that sits in her account. So I could do just 3 right here. She wants this value to be $600 in 3 months, so we could place that as 3. If you go back to the way I first described it, we could say it's 12, M, the number of compoundings, times the number of years. But 3 months is not a full year. It's only 1/4 of a year. But still notice there, either way, I end up with 3. So it's not necessary always to do that smaller little formula. You may be given exactly how many periods are required. So take a moment to write all the information that you can into this formula. And check behind me here that you have the same thing when you substitute your values. So again, we're looking for R. R is not isolated, but it's not too difficult to isolate it if we calculate all of this stuff here first. So I'm just going to do this smaller piece of the formula in my calculator. I don't necessarily need these larger outer parentheses, so I'm just going to go directly for the fraction key. In the numerator, I have a parentheses plus, 1 plus, and then another fraction. So use the fraction key again. Type in the numerator, denominator, move out of the fraction, close the parentheses, and then the exponent here is 3. Move out of the exponent, right, subtract 1, and at that point we have everything that's in the numerator. Move down to get to the denominator, and notice there's another fraction there. Type in its numerator and denominator. And what this value tells us is the equivalent to everything that's in this messy complex fraction right here. Okay, so I can rewrite what I have now as 600 equals R times this number. And I want to keep a lot of accuracy here, so I'm just going to write out all the decimal places. Now, solving for R is a matter of undoing the multiplication. So when we divide both sides by this 3 point something, we should isolate R. At that point, we've isolated R, and this is what R equals. So let's do that in our calculator. 600 divided by, and instead of typing it, you could even type second and then the negative key. You see where it says previous answer? It's just going to pull that same number right here. And I have that I need to make regular payments of $199.20 in order to get the amount in the account at the end of 3 months that I desire.